Hi, welcome to my talk about the illusion of control. Unfortunately, we are a little bit after the schedule, and my slides are a little bit cramped with content, so I gotta proceed really fast over the introductory part. It's also about game design decisions for games played at live events, or for example the Gamescom, like trade fairs. So really quick about the lightning talk version of the About Me. As said before, I'm a student at the Graz University of Technology, and also since recently I'm a game developer at Rarebyte, where we make pretty awesome, cool stuff. Okay, right to the meat. What's different at a live event? This is a picture I took at this year's Gamescom. As you can see, there are quite a lot of people, and you can imagine it in one word, like there are thousands of people and everybody's there, only there to play your game. So given that there's a limited amount of time, everybody only gets one try to play it. And yeah, well, there are queues, many queues. Some design requirements, which we had to incorporate in our project, which was that the play sessions were only about 3 minutes, so the game needed to be learnable in 30 seconds, which was quite a task. And we also tried to make it interesting for different levels of skill, so that a newbie player can compete with a pro player, and we got that part pretty well. Also, it needs to be interesting to watch to generate crowds in front of the booth, and it must run for many hours straight, and that's about that. So now about the meat of the talk. I'll be talking about the hover mechanics of our racer, which is demonstrated out there. We had to implement quite a few things to make all of those things work. And it was a contract work for Physic card. It was running at the Gamescom last week, I think, with quite a few players. And the game, in one sentence, that's the setup at the Gamescom. It is a game, a hoverboard racing game, supporting 4 players over the local network, played with Wii balance boards, and we had about 2 months development time. So we had to cut a few corners to make it work, but we did it, and I think we got it nice. As said before, I'm going to talk about the hoverboard controller mechanics. This is the first version after 2 days and the last version after 2 months. Ignore the fancy graphics, but let's start. I'm also a very talented artist, as you can see in my fancy programmer art. This was the first implementation of the hover mechanics, which was implemented using thruster points, where we would just send rays down at these corner points that we generated, and we orientated the hoverboard, using the average hit normal we got. The steering worked with physics, with torque at this moment, which made it pretty hard to control, as yes, you can see. And a few things we of course needed to prevent was that the board could still flip over and the player can drive in every direction he wants to, and of course the steering is bad, very bad. Okay, that was the start of the design. This was the next fancy version of our hoverboard. We tried to stabilize it using a higher drag value on the physics body. The steering still works with torque, and this was the first implementation that used real thrusters. So instead of orientating with the average hit normal, we send rays down at these corner points, and we apply a force at position at those thruster points that really simulate the way a real hoverboard would work. But unfortunately, how it works in real life is not the best way how to do it in a game, because it's very, very unstable. Oh, sorry. So we tried to fix this stability issues by just rotating the thrusters outward, which helped a bit to stabilize it because, yeah, but still very shaky. And when we added tilt, yeah, well. Yeah. So we had to fix that. So we got rid of the thrusters. We just used one thruster at the center of the hoverboard, which was basically the same mechanic, but just with less fancy real thrusters. The rotation was still done with torque. I should have really turned that up. So when you collide with the wall, as you can see right there, you just spin out of control. And okay, next step was to ditch Physic rotations. This already improved it quite a bit. We were able to steer very nicely. Of course, the player can still turn around, but it worked well. It doesn't look very well. That's why we added tilts, which is just the set rotation of the board, which provided additional steering support because the hover force of the board would push it in the direction he is facing. And now the next thing that went missing was that the player won't orientate on walls, because with the old implementation with the hover points, we had that kind of out of the box because it would just orientate along that. But with one hover point we need to implement that ourselves. So yeah, the calculations were a bit messy. It was a pretty tough change because we had to change the frame of all our calculations to take this new base rotation into account. But the player can now drive on walls, and it's already pretty good. Let me quickly turn off my volume. Okay, I can't find the mouse, never mind. It's already pretty good, but the only problem remaining is that the player can still turn around and drive in every direction he wants to, which is something we really wanted to prevent, because then you have those trolls at the conventions that just drive in the wrong direction and the game never finishes. And yeah, we needed to prevent that. So the next thing was to preventing the player from turning around. Therefore we needed a track guidance, which we implemented using a spline to define the track. And when we did that, we had the direction that the player needs to face at every point on the track. And then we just needed to make the player follow the track, which was pretty easy. Just calculate the nearest point on the spline. But yeah, there's no way to control the player, and he's just rotating in the direction of the path direction, which looks, it's not usable. You can't use it like that. So the first thing to do was to make the player able to steer again, which we did with a path offset. So now we can move this little steering thing orthogonal to the path direction, which allows you to steer the player, but it's totally indirect and it's not usable like that, because he just tries to take on the position of the steering point, which makes him bounce around because he's moving there with physics. And then we come to our working version, which is still in the final release of the build. Our artist had the ingenious idea of moving the steering point in front of the player. Unfortunately, I don't have a GIF of the scene view right now. But the steering point is now driving in front of the player, so always somewhere around there. And the player always tries to look at this steering point, which lets you control, and the steering point can be controlled along the path like before. So you have a pretty direct feel and control of how to move your player, because you can actually control the way where he looks, instead of just letting him take on the position of the point. And nice side effect, we got a free bot, which we used extensively in development, because you can't always test with 4 players. And that was kind of the point of all of this development. We needed to provide the player with enough support to make it through the track and to eliminate skill in a way that doesn't eliminate the fun. And I think we got it pretty nice. You can try it out outside in the hall. It really looks, for the player, it feels like he's controlling the hoverboard. And when we tried it with one of our testers and I told her to get off the board and the board just kept on driving, she felt kind of betrayed, but that's the point. We added, that was after about 2 weeks of development, and after 1 month more, with all the fancy effects added, we ended up with this, where we added additional character animations that were directly bound to the player input. So whenever the player leans forward on the balance board, the character animation also leans forward and backwards, which made it feel instantly direct. Also added camera rotation, so the tilt when he moves around, and also some things like the steering speed that is depending on the movement speed. Like in real life, when you're driving really slow with a bike, you can make very close circles, and when you're driving very far, you can't steer like that. Oh, sorry. You saw our bloopers. But anyway, that's basically it. Oh, I made it in time. That's cool. Those are a few development gifts, which are pretty nice. Those are the things that happen. Well, thank you. And are there any questions? I think we have a few minutes.
Okay, there's a question from Twitch.
Yeah. So they asked which technology and programming languages were you using?
We were using not only. We were using Unity. It's our main development engine at Rarebyte, but we also had to use a special input library for the balance boards, because it's pretty hard. You don't get your hands on the original balance boards that were from Nintendo, so we had to buy how are they called, the remade ones from, I don't know how the company is called. And they are not really supported by any driver, so we needed to implement custom middleware that would pipe the balance board input into Unity using a socket. Yeah, it was a development process, and Unity and this little server, I think that was developed in C++, if I'm not wrong. Yeah.
We have time for one more question. Okay, so thanks again to Peter.